Welcome back. This is Mr. Marshall for Truganina College, Year 9 Maths. We're looking at measurement and geometry. This is lesson 5 and we are looking at composite shapes. Our learning intention today is we are learning to calculate the area of composite shapes, and our success criteria is I am successful when I can identify which formula to use when working with composite shapes. I can calculate the area of individual shapes, and I can add or subtract areas to calculate the area of a composite shape. Just a reminder, our basic shapes that we looked at over the last couple lessons for areas, we have the area of a square, which is length squared. We have area of a rectangle, which is length times width. We have area of a triangle, which is half base times height. We have area of a circle, which is our pi r squared. Area of a parallelogram, which is just base times height. And area of a trapezium, which is half of the two parallel sides added together, multiplied by the height in between those two sides. So let's look at what a composite shape is. Composite shapes are a shape that's made up of smaller, simpler shapes. So if we look at the composite shape here, we have two half circles. There's one half circle, there's the other half circle, plus this square here. And because those two half circles have the same diameter, we can actually make a full circle out of that. So if I worked out the area of this circle and the area of this square and then add them together, I could get this total area here. And for a subtractive area, I look at this and I can see I've got a square here and I've taken away a half circle here and a half circle here. If I take away a half circle here and a half circle here, that's the same as taking away a whole circle. So here's some steps that we do to make sure that we can work out a composite shape. So step 1 is identify the shapes that we need to do to calculate. So we break the shape up into smaller shapes. We then identify which formulas we need for those shapes. We check the units and we make sure that all the units are the same measurement. If we're working in meters, everything's in meters. If we're working in centimeters, everything is in centimeters. We calculate the individual areas of each of those shapes, and then at the end we add or subtract the different areas together to create the total area of a composite shape. So here's our composite shape example. I have my shape here on the right, and I've been asked to calculate the area of this shape. So here's my thinking, and here's what I'll be writing. So I'm going to start off by identifying what shapes we need. And I can see that I have a rectangle, 16 centimeters across this way, 12 here, there's my rectangle. And I have a triangle, which is this one here. Now we know that this distance here is 12 because it's the same as there. But the distance for the height will be from here up to the end. And we'll have to work that out. And we work that out by going 24 minus 16. So that's 8 centimeters to work out that height. So let's work out our formulas. And at the same time, we're going to calculate the individual areas. So our triangle is area equals half base times height. And as I said, our base here is 12. And our height, distance from there to there, is 8. And we type that in our calculator, we get 48 centimeters squared. And for the rectangle, that's nice and easy. We have 12 by 16. And that works out to be 192 centimeters squared. And because we're adding this rectangle to this triangle, we just add the two areas to work out our total area, which is 240 centimeters squared. And this is our workings for these types of questions. Here we have another shape, and this time we're asked for both the perimeter and the area of this composite shape. So starting off, I'm going to do my explanations and solutions. We look at this, we've got 3 sides and a curved side. So I'm going to go 2 times length, because we've got 1, 2 there, plus the width, which is here, plus half, because we've got half a circle, times 2 pi r, because we can work out the radius is 7. We put all those numbers in, we type it into our calculator, and we can solve it roughly to 69.99 centimeters. Because this is perimeter, we're just using our normal units, centimeters. Next, we're going to work out the area. Now the area is, we've got a rectangle and we've got a semicircle. So again, length times width is our area for our rectangle, plus half of pi r squared, because that's our half circle we've added on. Again, we put in all the numbers, we substitute it in, and then we type it in our calculator and we can solve it. And our answer is 314.97 centimeters squared. Because we're talking about area here, we've got to make sure that the units are units squared. Here's another example, but this one is a subtractive example. We have our shape here that we need to work out. Again, what we think and what we write. We're going to start off with identifying the shapes again. And we can see we have this big rectangle and we have a small square. We are going to apply the formulas and calculate the individual formulas again at the same time. So square is area equals length squared. So area equals 2 squared, because there's our square, which is 4 centimeters squared. And our rectangle is length times width. 16 times 8 is 128 centimeters squared. And then in this case, we're going to subtract the 2 numbers. So 128 minus that 4 centimeters squared, because we're taking it away, equals 124 centimeters squared. So for practice this time, you're going to be using your Jack Plus Maths books, either online or the actual book or the PDF that you have, and you're going to be working, for students who are at the practice level, you're going to be working on these questions here. For students at consolidating level, you're going to work on these questions here. And students at the master level will be working on these questions here. Our reflection for today: which composite shapes did you find the easiest to calculate the area of, and why is this? And which ones of these did you find the hardest to calculate the area of, and what did you have to think most carefully about when calculating these? Once you've completed all your work, you will need to upload it to our Google Classrooms so that you will be assessed on this.